Okay, this configuration corresponds to current series topology. So that is what we have seen. And now immediately after drawing the circuit, we will draw the low AC equivalent circuit. So AC equivalent means I will be removing I will be short circuiting all the capacitance. I will be short circuiting all the voltage source, and I'll be drawing the AC equivalent circuit. So in the AC equivalent circuit, if you see if you apply KVL in the input side, you have to consider RE. If you apply KVL at the output side, you have to still consider RE. So this RE can be split across input as well as output and directly grounding your emitter. So instead of having an element common to both the loops, I can have this element in both the loops and I can directly ground my emitter. So that is one simplification I'm going to do to the diagram. See here, the same diagram. You see, emitter is grounded and RE is present in output loop as well as RE is present in the input loop. And across RL, I'm going to measure my output voltage, and the current flowing through RL is going to be I naught. But whereas your IC will be flowing in this direction. This is going to be the collector current direction. Okay, so the output circuit is replaced. Output circuit and input circuit are both analyzed using the AC equivalent circuit. So I'm going to split this resistance RE across input and output side. See, I'm not writing it as RE by 2 and RE by 2. RE by 2, RE by 2 I can put when I'm going to split the resistance into two series component, but it is not in series. I am writing RE across two different portions of a same network. So RE is shared between input side fully and output side fully. Okay, so the emitter, I am going to ground my emitter directly. So after this, you draw the AC equivalent. You will be replacing the transistor with the equivalent H parameter model. So see here. So it is very simple. We consider only HIE will be there for the transistor. So RS and RE will be there. Output side you have HFVIB followed by RL and RE. And as we seen, I am going to take the feedback voltage across RE. See the notation how plus minus is given for VF. And the current flowing through RL is I naught, and I naught and IC will be opposite in direction. So I can write I naught equal to minus IC and IC equal to HFEIB. And the current entering through the amplifier, current entering through the base terminal is IB. Since I have only one loop here, so II will be equal to IB. All the currents are going to be same. And whenever you find R naught is excluding your load. And R naught dash is including your load. Okay, please understand the notation in the diagram. I hope we have seen it long back in the offline class. It is better you recollect all the notations to be followed for all these types of amplifiers. So this topology is going to have transconductance GM. So the GM is going to be output current by input voltage, I naught by Vs, I naught by Vs, or I naught by Vi. So beta will be reverse of that, Vf by I naught. It's going to be Vs by I naught, but you know for beta we'll replace the suffix by F. So beta is equal to Vf by I naught. Okay, and Vf you know it is minus I naught into Re. Why minus I naught? I naught is flowing in this direction. Always current entering node is positive, leaving node is negative. But see I naught is generating potential in this direction, but what is actually measured VF is in this direction. Both are going to be opposite. So VF equal to minus I naught into RE divided by I naught. So I can cancel out this I naught. So beta is going to be minus RE. Negative sign, you know, it is because of the 180-degree phase shift, which is going to be introduced by your common emitter amplifier. So any amplifier, if you're asked to derive, first identify what amplifier. So only 4 types of amplifiers we have. Voltage gain will be there for that amplifier, current gain will be there, trans conductance will be there, or trans resistance will be there. So for current series, we are getting trans conductance as our parameter, so GM. Okay, for remaining 3, you will be getting the other parameters of the